So how do you know where to start? So here I see a radical, and it looks like something squared plus something squared. So let's just even take the time to decode that. So you'd have a dx and x squared, and so that's the same thing as saying a 3x quantity squared plus a 1. Oh, I see it. So that means this is like an x squared plus an a squared. So the x equals a 1 tangent of theta. All right, before I take the derivative, I'm going to divide through by that 3. So dx is equal to 1/3 secant squared theta d theta. So be very careful plugging everything in. Remember, this should get huge. So I'm going to take out dx and put that whole big thing in. So 1/3 secant squared theta d theta. All right, x being squared. This is x. So I get a 1/9 tangent squared theta. And then let's see what I've got here. So I have the square root of, instead of 3x, I'll put in tangent squared theta plus a 1. Remember, you're always looking for the identity that's inside the radical. So this 1/3 divided by a 1/9, that gives me a 3 on the outside. So I get secant squared theta, tangent squared theta, and then this gives me a secant. All right, so then one of the secants cancels. So I get a secant theta over a tangent squared. This is not one of your normal peel off a secant tangent thing. So it is necessary to rewrite these in terms of sines and cosines. So I'm going to go slow. Sorry, that's kind of messy. So tangent, is sine squared, or tangent squared is sine squared over cosine squared. Okay, so I'm going to take the time to rewrite this. So I get 1 over cosine times cosine squared over sine squared. All right, let's cross that out so we can keep going with this one. So I end up, one of the cosines goes away. So I get 1 cosine in the numerator and then a sine squared down here. Again, this is not one of your normal peel off things with sine cosine combos, but I think you see it. If I do an easy u substitution, then the du is the numerator. So carry the 3, so I get 1 over u squared du. So that's 3 times negative 1 over u. I'm going to go slow, so I put all those things back in. The u was sine, okay, plus a c. And then, oh man, how do I get back to axis again? That is where you go back to the original substitution. So let me bring it down here. So 3x over 1 is tangent of theta. So that's where I make the triangle from, right? So opposite over the opposite over adjacent, right, is tangent. And then if I go find the other side, which I will need it to find sine, is 3x squared plus a 1. Oh, look at that happy moment. That's what we had in our original problem. So then I just take this negative 3. The sine of theta would be opposite over hypotenuse, so 3x over 9x squared plus 1 plus a c. So let's fix that up, right? That's kind of ugly looking. So I'd have a negative 3 root 9x squared plus 1 over a 3x plus a c. That was number 1.